All right, we are looking at 12.7 on dilations. Dilations, think of like somebody might say your eyes dilated, something like that. It means it grows, it shrinks, it changes. Okay, so a dilation is the last type of transformation that we'll be seeing, and it's the final section in the chapter. Use this, we will recall similarity properties. Remember things like similar triangles and such. Matrices, something you just learned earlier this chapter. We'll use these things to transform figures with dilations. And we will enhance our knowledge of coordinate geometry by gathering information from looking at figures. So again, we have to remember some things about coordinate geometry, using coordinate points and doing stuff with those. Just keep those in mind. All right, a couple definitions here. They all kind of expand upon one another. The main one here, dilation, it is a transformation, so the last type, whose preimage and image are similar, but they're not congruent. So dilations are not isometries. So if you take, for instance, a square here, okay, and I want to transform it, normally a reflection, rotation, translation, or glide reflection, I still end up getting a square. It might be an opposite or direct isometry, but it's still an isometry nonetheless. A dilation would be taking this square and perhaps making it grow. Okay, perhaps making it shrink. Maybe this is my square. All right, but these are dilations of this square. They're similar, if you remember what similarity means, but they change their size. All dilations have a scale factor and a center. So I think you know what a center is, but we'll talk about that more in a bit. You have to figure out what scale factor means here. Scale factor is a ratio that describes the size change from image to pre-image. So it's like similarity ratio, if you remember that. Only now we're going to go backwards. We're going to go from image to pre-image. So let's say this, let's say my original image, my pre-image, has a side length of 1. And when I grew this had a side length of 3. The ratio, the scale factor, is 3 to 1, or 3 over 1, or 3. Normally, you will see this one more than anything else. You will normally only see a fraction if it needs to be a fraction. Let's say it was the other way around, 1/3. You would have to put it as 1 over 3. This you don't see too much, but you could say if the scale factor was 3 to 1, then you knew that your image was 3 times bigger than your pre-image. Okay, so it does go backwards. Just keep that in mind. So when it says there's a dilation with a scale factor of 3, that means your original image is 3 times smaller than your transformed image. Your transformed image is 3 times bigger. So an enlargement is a dilation where the scale factor is greater than 1. In this case, 3 to 1, 3 over 1, 3. These are greater than 1. That means this was an enlargement. This grew. Okay? And a reduction is where a dilation, is a dilation where the scale factor is less than 1. So if I look at this small one here, let's say this size was 1/3, and the scale factor was 1 over 3, like that. This would be considered a reduction. It might say a dilation with a scale factor of 1/3. What are the sides, or what are the new sides of this thing, and was it an enlargement or reduction? Okay. Okay, let's recall similar triangles again. Now I have 2 triangles here. There's this one kind of creeping up from behind, this red triangle, and then there's this blue triangle. Now the blue triangle, you have to figure out how much bigger it is than the red one. So here I have a side length of 4. And this segment is 4 units, but we have to figure out the rest. So what are the known side lengths of the smaller triangle ABC? So we know that there's one side length that's 4 and another one that's 5. I'm just going to go ahead and put them like that, 4 and 5. What are the known side lengths of the larger triangle, A prime, B prime, C prime? Well, so this whole side is 4 plus 4. So this is 8, and this whole side is 5 plus 5. So that's 10. This is stuff we've learned in the past. It probably should not be too difficult to recall, but as long as we can, then we have good hope for this. If triangle ABC was the original triangle, if we saw this as the original one, and A prime, B prime, C prime is the transformed image, what is the scale factor of this dilation? Is it an enlargement or a reduction? So remember, when we do scale factor, we have to go from image to pre-image. In other words, saying, let's divide this value by that value. So let's say 8 over 4, which is 2 over 1, which is 2. So it has a scale factor of 2. And is it an enlargement or a reduction? It is an enlargement we went from the small triangle, we enlarged it to the bigger triangle. So I'll just put enlarge. Okay. Now, if we looked at it the other way around, let's say the blue one was the original image, the red one was the transformed image, then the scale factor would be 1/2, and it would be a reduction. And if you notice, well, I think I label it later in my notes, but you'll see that we go A, B, C, and A prime, B prime, C prime. That's nothing new, but this will be very important for dilations. We are not going to change the letters ever. I won't say A, B, C for here and D, E, F for this triangle. We want to make sure that we correspond them exactly because we want to note what the actual similarities are. This will be important for centers, which is what's next. Center of dilation is where, to find the center of dilation, just keep these things in mind. A pre-image and image have corresponding vertices. So that's what I was talking about there. So R is to R prime, here M is to M prime, stuff like that. So they have to correspond and you have to note where they are. Together they travel the same direction away from a center C. So let me look at all of the, here. So they travel the same direction away. So for instance, these go on the same line together. If I find that line, I just keep drawing that line like so. And eventually I'd find a center going on that line. And same with going on that line. But I'll do that in a second. So to find the center of dilation, follow a path that all vertices go. I just say go to until they meet. So let me go ahead and draw some paths here. From J to J prime, they do this vertical line thing going downward. And these probably won't be exact here. M to M prime goes straight through like that. L to L prime, they all follow this path. And K, K prime, etc. They all follow that path. Whoops. They all follow that path. So where do they meet at? Right there in the center. Or right there at the origin. And that happens to be your center. So you kind of have to draw straight lines there. Hopefully you draw things to scale. And same thing if you have the center and maybe the transformed image, you can draw it out until you need to find the image if you have that stuff, etc. So we followed a path that all vertices go to until they meet. So follow J and J prime together to the center, etc. So keep doing that with everything. So here's an example. As we said, the blue quadrilateral is the dilation image. Looks like a reduction from my pre-image. And we have to describe the dilation. So the three ways we need to describe the dilation are we need the scale factor, we need enlargement or reduction, and we need the center. So first let's do center. Our center is at 0, 0. We found that out. Is it enlargement or reduction from red to blue? We reduced it, so reduction. And scale factor, keep in mind, in similar triangles, when I did 8/4 here, that gave us 2/1. 10/5 should give us the same thing. So whenever we enlarge or reduce something, because they're similar, because these are similarities, they're similar, we should get the same scale factor for everything. So we should only look at one of these. I don't think it would be useful to be going over on L and counting how far away that is, how far away that is. Let's use the easiest ones, like this one right here. From the center to J prime, it's 1 unit away. From center to J, it's 2 units away. So we go from image to pre-image. So we were 1 unit away from J prime and 2 units away from J. That means our scale factor is 1/2 or 1/2. So we reduced everything by 1/2. And you can double check that with maybe one more example here. From here to K prime, from center to K prime, it's 3 units. From center to K, it's 6 units. 3/6 is also 1/2. Okay, so that's our scale factor, 1/2. So that's how we describe the dilation: scale factor, enlargement, reduction, and center. Okay, more about scale factors and scalar multiplication. Working the other way. If we have the center and we know it's at the origin, which is 0, 0, and we have a point x, y that we need to dilate. So let's say right here our point is like x, y, something like that. And we need to dilate it from here with a certain scale factor. They'll tell us what it is. Just go ahead and multiply both those points by that scale factor. So example right here, if our scale factor is 4, we have a point x, y. Our transformed image is 4 times x units away from the origin and 4 times y units away from the origin. So if I were to give this example, which I just drew here, my xy is at 2, 4. Okay.